So we'll go ahead and get started. Good morning, everyone, and thanks for coming to this session. My name is Nihar Bihani. I'm a product manager at Amazon Web Services, and the specific product team that I'm a part of is Amazon CloudFront, which is our content delivery service. And we're here to talk today about best practices for handling a 20 times traffic spike. So let's get right into it. So I'd like to start with a true story. So there is a popular entertainer a couple of years ago. What they did is they sent out an email to all of their customers at the same time. What they wanted to do is tell their fans and customer base about their upcoming tour dates. So they send out this email, and all of their fans go to their website all at the same time, and guess what happens? The site is not available. The fans cannot access the site. So, this is exactly what we're here to talk about today and share some of the best practices. I'll start out with some audience participation here. So have you, just by show of hands, have you ever had to prepare for a big online event? Okay, several folks. Have you had a surprise surge in traffic that you didn't expect? Okay, fewer folks, but still quite a few. And have there been outages or performance issues that you've seen related to these spikes, whether they were expected or unexpected? A few folks. So, in today's session, what I'd like to do is first talk about, just a little background on the different types of events that can cause a large traffic spike to your application. And then second, I'd cover some of the best practices. There are 4 best practices that I'll talk about. The first 2 I'll dive deeper into. And then the last 2, I'll just leave you with some thoughts so that you can think about those as well as you're architecting for traffic surges, even if you don't expect them. So let's take a quick look at what are the different types of events that can cause a large traffic spike. So the first one is, the types of events that you can kind of predict. Right? These are the anticipated events. Could be a product launch, could be a marketing campaign that you're about to run. So the questions that you want to ask there is, have you analyzed and predicted the traffic distribution and the traffic pattern for that event? And then have you set up the resources correctly? And then compared to that, the second type of event you can think about is going viral, where it's an article in a popular news outlet that gets picked up, or you get popular on social media or Twitter. And we've also learned that some varieties of these where after you unravel it, it's actually a partner that's doing a load test against your application that you didn't even know about. So that begs the question: if you don't anticipate the traffic, how do you actually plan for that? And the biggest thing I'd like you to take away from today's session is that the way you prepare for handling a traffic spike, the steps that you need to take should be independent of the type of spike, whether it's anticipated or not. And the most common failure points that I have seen when I've talked to customers is incorrect caching policies or an unscaled origin. So that's where we'll spend most of our time today. So here's a very highly simplified architecture. Basically, what I've shown here is 4 different types of clients that are trying to access an application that runs on a host over a network. And what I've shown here is each of these 4 types of clients that are each sending, let's say, 25,000 requests per second for a total of 100,000 requests per second to your application or to your host. And also, each client type is sending, let's say, 5 gigabits per second or 5,000 megabits per second. So the impact of such a flash crowd, there are 2 ways in which this type of traffic load can impact your application. First is the high rate of request. If that happens faster than your application can actually scale up, then that can cause availability issues for your customers when they are seeing 500 CGS errors and are actually not able to access the application. The second area is the high data transfer rate. And all of the bytes that need to be delivered to your customers can cause browning out and can cause retransmits in the network interfaces across the various levels of your application stack. So the net of all this is this impacts your customers in 2 different ways. Increases the latency for them in accessing your application, and also can potentially cause availability issues. The best case scenario is, of course, where the customers are having to wait longer, and the worst case is where some customers can't access your application at all. So let's talk about some of the best practices when it comes to preparing for some of these events. So the first and the most basic thing that you can do is just use caching, and use caching as much as possible for your application. So I've got the same architecture back up on the deck here, and what I've done here is added a layer of caching, right? So I've assumed a 10-to-1 cache hit ratio. That's kind of the rule of thumb. Your mileage can vary, depends on the type of application. Some applications can get much better performance, others don't do as well. But if you assume a 10-to-1 cache hit ratio, now what's happening is the cache servers are handling the vast majority of the traffic, and only 2,500 RPS per client type, so for a total of 10,000 instead of the 100,000, is ending up on your hosts. Similarly, on the caching can help protect your network as well. So here again, assuming that same 10-to-1, instead of the 5 gigabits per second, you only have half a gigabit per second or 500 megabits per second from each client type that's ending up on your network. So this helps minimize the retransmits. This helps keep your latency high as well as the availability. So when it comes to caching, Amazon CloudFront, that's the product team that I'm a part of. We have edge locations across the world, 53 locations currently across 37 cities. So that's one way, using a CDN like Amazon CloudFront can help you get that kind of edge scaling so that you can minimize the amount of traffic going back to your origin. But when it comes to caching, think about other things as well. Like think about the browser cache, right? You can set different cache control headers, which we'll dive deeper into, so that you are also letting the browsers or enabling the browsers to cache your application. This is the best kind of caching that you can get, because if the browser is locally caching your objects on the customer's device, then there is no requests or no bandwidth going out of the customer's device at all. So this is the best kind of, if you think about it. But browser cache size is limited, so that's where you have to fall back on things like using a CDN or a shared cache. And just think about caching up and down your stack, right? We talked about browser caching, we talked about edge caching. There's also caching at the origin tier, so you can put, a lot of customers use things like Squid, Varnish, and Nginx to create a caching layer in front of their origin servers. And also, a lot of our customers use Amazon Elasticache, which is another AWS service, for their database access tier, so create caching. So you can think all the way from the database tier, web tier, edge, and the browser. So in terms of best practices, in addition to caching, one thing that I'd like to dive deeper into is just using caching correctly. And what I'd like to do here is talk about 6 different cache control headers, and what each of these cache control headers can help you do when it comes to the caching semantics of your application, and how you can maximize the caching and minimize the traffic going back to your origin. So the most basic one here is Expires. I think most of you are familiar with that. The Expires, this is an HTTP header, and the way it works is, in this example, I have a specific date and time, so Tuesday, November 4th, 2014 at 7:19 a.m. GMT. So at that specific date and time, until that date and time, any cache can trust that this object is still fresh and serve that object to your customers without checking back with the origin. After that date and time, the cache must check with the origin to see if the object is still fresh, or if it has expired, or if it is stale. And you'll notice I'm being deliberate about, the cache will not go and get the object right away from the origin. It'll only do a check, which is an if modified since request. And the origin can respond back in one of 2 ways. It can say, no, the object has not changed, and just return a 3 or 4 response. Or the origin can say, yes, the object has changed, and here's the full object. So the net of all of this is that even if there's a stale object in the cache where the expiration date has passed, you will still be protecting your network from the bytes, although the request will go back to the origin if the origin hasn't changed, or if the object hasn't changed at the origin. A more popular one that I see customers use is MaxAge. So what this allows you to do is provide a relative time instead of an absolute time like Expires does. So you can say, hey, in 60 seconds from now, this object will be expired. And a variant of this is the S-MaxAge, and this is something that some customers don't know about. But what S stands for shared, and what this helps you do is this is a way for you to specify a different time to live for shared caches versus the versus the MaxAge, which is for browser caches and other private caches. So the reason this is helpful is with browser caches, there isn't really a good way to invalidate the objects that end up in the browser cache. So if you only use MaxAge, the browser will cache it for that amount of time, and if the object changed, you wouldn't have a way to invalidate that. So what customers do is they use a lower MaxAge value, like say a 1 second or 2 seconds, so that the browser is checking back with the shared cache frequently. But on the shared cache, where there is a good way you can make an invalidation API call, you can set a longer TTL, or time to live. The other three cache control headers, those are really, they're similar in the way that with these headers you can specify how you write objects to disk, or how a cache should write object to disk. But they're slightly different, so I'll cover them quickly. The cache control private, what this says is a shared cache may not write this object to disk, but browser caches can. So you would want to use this for things that are either user specific or sensitive or private, that you don't want to end up on the shared cache. A no cache says that a shared cache may cache the object, but has to check back with the origin server upon every request. So unlike private, where you want to use that when things are user specific or sensitive, the no cache you would use where you're anticipating it changing. And then finally, no store is where you're saying that neither the shared caches nor the browser caches may cache this object at all. So those are the 6 different cache control headers that you can use to really help maximize the caching for different types of content that you're serving. And when I look at CloudFront and some of the types of content that customers are serving, serving static content like images, JavaScript files, CSS files. There's video on demand content. There's dynamic content like personalization on a page. You have user input, where it's you're actually sending data back to the origin, and then also SSL or SSL certificates. So for each of these different types of content, think about which cache control header you should use, where you would want it to cache, because again, to prepare for a traffic spike, your goal is to minimize the amount of traffic that ends up back in your own host and your own network. So that's just a summary of that. Just cache everything possible. A lot of the content can be cached. And think about how if modified since works, and the way I described it, where the caches will go and check back with the origin if the content has changed or not. So you can set different time to lives or TTL values for that content. And the added benefit for this is a shared cache like CloudFront or a CDN will actually serve your content even if it has expired, as long as it's in the cache, when it can't reach your origin server. So if your origin server is unavailable, you can still get the benefit, and your customers are still viewing that object, even though it might be stale. One quick way to identify what are the different types of objects on your site that you can cache, just look at the popular objects report and look at the cache hit ratios. You'll find that there are some URLs here that you wouldn't have traditionally thought that they could be cached. Because they may be customized with a query string or something like that, but you can still cache some of those URLs. So there may be benefit even if you wanted to cache them only for a few seconds. And the last thing I'd say is always configure custom error pages. Custom error pages allow you to provide a customized branded experience to your customers even when your site is unavailable. So this is just a good best practice from that regard. So those were the first couple of best practices. The last two, I'd run through them quickly, and just leave you with some thoughts to think about as you're architecting an application. The first one is scaling your origin servers. So here, by far, the best way we recommend to our customers is using auto-scaling, which is a feature of Amazon Web Services. And auto-scaling allows you to configure triggers based on scale-up or scale-down events in your application that helps automatically add resources to your origin server as either load goes up or load goes down, or traffic to your origin server goes down. So again, this could be a whole talk in and of itself, so I wouldn't dive deeper here, but just wanted to highlight that you should think about how you can help scale your origin resources as well, in addition to using caching at the edge or taking advantage of caching that the browser does. Also think about how you can design for failure. There are options available where if your origin server is unavailable, so in this case, CloudFront is trying to access an elastic load balancer with some EC2 instances trying to access your application, but if for whatever reason that origin is unavailable, you can use Amazon Route 53, which is an authoritative DNS service that AWS provides. And at the DNS layer, what Route 53 is doing is it's conducting health checks on your origin server. So you have two different origin servers. It's conducting health checks constantly, and as soon as DNS finds that one of the origin servers is unavailable, it automatically helps direct CloudFront to the second origin server, which is still up, so that CloudFront can still get the content from your application. And the last thing I'd quickly touch on is, let your origin do only the work it needs to. So, I like to think about this the way we think at Amazon Web Services, which is, doing the undifferentiated heavy lifting for you. So we provide those services where you don't need to necessarily run them and manage them. So I apply that to your origin as well. So for instance, for static content, just use Amazon S3. Amazon S3 is, a static object store. It's highly durable, highly available. You can put all of your static content that doesn't change very frequently or that doesn't need to be computed for every user request in S3. And then you can configure with CloudFront on the CDN what we call cache behaviors. And what cache behaviors allow you to do is based on URL path. So let's say for /images, you point CloudFront to your S3 bucket so that CloudFront can fetch those images from S3 when your viewers request them. And but for things that are personalized or customized to your viewers, CloudFront you can configure CloudFront to go to an elastic load balancer or your own origin server or a web server that you're running, because something needs to be computed every time for you to be able to serve that object. The other thing that cache behaviors allow you to do is specify for which object path, what types of headers you forward, what cookies you forward, user agent and things like that. The goal here is to minimize what you forward back to the origin server so that you can maximize the cacheability of your content at the edge. The more things that can be cached, the fewer requests and fewer bytes need to travel over to your origin servers. Just a quick note on live streaming. When you're doing a live stream, so most of what we talked about so far was an application with some static content or a video. But even when you're doing live streaming, you can use a CDN like CloudFront. And one of the key features that CloudFront has is when there are multiple requests coming in for the exact same object at the exact same time, CloudFront will consolidate them and send fewer requests back to your origin. And that's very typical when you think about a live stream where all of your viewers are requesting the manifest and the fragments all at the same time. So this is a great way to minimize the load on your media server that's actually generating the manifest and the fragments by putting a layer of caching in front of that. And you can use different time to live values as well. So you can set a time to live of, say, 2 seconds on the manifest file, which is short because the manifest file is constantly updating. A high TTL for your actual fragments. And then a media player could be an even longer TTL and could be coming off of S3. You don't need that to be delivered out of your media server. And the last thing I want to talk about was just how you can set alarms, or how you should be thinking about setting alarms and monitoring your traffic for these spiky events. So even if you have prepared, you would want to know when you're getting a large spike in traffic. So one of the things that CloudFront offers, for instance, is some of the operational metrics that are available in near real time. and you can get them through Amazon CloudWatch, which is our monitoring service. And you can set alarms on things like number of bytes that CloudFront is delivering, number of requests, error rates. So this way you can get notified proactively when there is a traffic spike. And hopefully if you're prepared well, you wouldn't need to do anything. You're just watching the metrics. But otherwise, you can also be reactive and try to go fix things quickly. So that's all I have. I think we have a couple of minutes, so happy to answer any questions. Yeah?
Question about auto-scale. Have you got any recommendations for downscaling? Downscaling is traditionally quite complicated with auto-scaling. You end up with one user on 100 servers, on each of 100 servers, rather than downscaling back to 100 users on one server. Are there any tips or techniques you've got for handling downscaling?
Yeah, so the question is about auto-scaling and tips or recommendations around downscaling. For the most part, auto-scaling does that automatically for you with the triggers that you configure for scale-down events. But I'm not an expert on auto-scaling at all, so I'm happy to connect you with the right folks. There are also some resources available, but if we talk after the session, I'll be happy to get you connected. Yeah. Yeah.
With regard to caching your origins using Squid or Nginx, or Varnish, within Amazon, which of those three, or maybe even Apache, do you see most commonly used?
I think all three. I mean, there isn't a specific. We actually, don't necessarily know what customers are running, because at the end of the day, we're giving customers an EC2 instance, and they could be running any of those applications on that. From my conversations with customers, it's literally all three. It just depends on the use case. Depends on some of the functionality that's available in one versus the other, or what your specific use case is. But yeah, there isn't a specific pattern that I could, that's another area we can sort of dive deeper into to understand what your use case is and, figure out, hey, which one might be the best for your specific use case. Yep. Okay, great. Well, thanks so much. I think we'll be available here. We have a little bit of a break, so happy to answer more questions. Thank you.